We are moving to the coding part of our learning on linear regression. Here we are going to use the Jupyter notebook as the IDE for Python. One more thing I just want to mention here clearly is, instead of writing the coding, I am going to copy the code from a notepad to this Jupyter notebook so that we can efficiently and effectively use our time, instead of wasting our time typing the code and every time we have to check syntax wise correct. If any syntax error comes, then we have to correct that one. All those things can be eliminated when we are copy and paste the code from this notepad. And here the notepad, I have already written the code, and it has already been tested syntax wise also, so it's working fine, so that we can concentrate only on how the linear regression can be explained and can be explained step by step, instead of concentrating on the code. And wherever it is required, I will also explain what the code is doing. So first thing is, we need to load all the Python packages required for our model, for which what I do is I copy this code and paste here, and once it is pasted, I will press shift and enter simultaneously so that it can be executed. In the packages we are loading are NumPy, Pandas, these two are for data processing, and matplot library and Seaborn, these two are for generating charts. And we are using some models from sklearn for our linear regression. One is for splitting the data into training data and test data, and another one is for linear regression, and the third one is the metrics, and that is for evaluating our performance or finding out our performance measurement values. So these packages have been loaded into our Python environment. The next thing is, we need to load our data. The data is available in this path, so I am loading this data. In this path, the data is available, that is called e-commerce customers. Once it is loaded into the Python environment, in the data frame is named as customers, that is shown in here. So we are loading into our environment in the data, and the data frame is assigned with a name called customers. So customers is our data frame. The next thing is, we need to understand about the data, for which we are using customer.info open and close parenthesis. This function will get the details about the data set, that is the customer's data set. Okay, then what we get the result as is, it contains 500 observations. 500 observations means 500 records, and contains 8 columns. The columns are named as email, address, avatar, average session length, time on app, time on website, length of membership, yearly amount spent. And the data type, when we see the data type, the first 3 are object type, and the last 5 are float 64, the numerical variables. To have some sample of this data so that we can understand clearly about this one, then we will use the code customers.head. The head function is used on customer data set. So it will bring up some sample data from the customer's data set, from which we can have some idea about the columns or the values of the columns. So the email contains email address contains the location address for the customer, avatar contains something they have chosen for identification, and the remaining are the numerical variables. Again, the first 3 variables, when we see this one, these are all used to identify the customer or communicating to the customers. These 3 columns are not useful for our linear regression, because any changes in this column will not impact our linear regression model. So these are all not interested. Then we will see into the numerical variables. that is average session length, time on app, time on website, length of membership, yearly amount spent. So here the average session length is there might be the customer might have come to our site hundreds of times, then average time they are spending in our site, that is captured in the in our site or in our app, that is captured in the average session length. And the next one is the time on app. Time on app is how long, the total times they have spent on our app. And the third one is time on website, that is total time spent on our website. Length of membership, how long they have been with us, what is their length of membership with us, that is generated by this column. And the last column is a yearly amount spent. This is much important, how much dollar they are spending using our e-commerce site. That is very much important. Every customer, it is average yearly amount spent by every customer. Here, the one more thing I just want to mention, another one thing is the average session length. When we are talking about average session length, it may be seconds, 34.49 seconds, 31.92 seconds. And the time on app may be hours, 12.65, 11.10. Likewise, it may be hours. And the length of membership may be in years, 4.08 years, 2.664 years. What I need to mention here is the unit within the column should be same, but among the column may be different. For example, the average session length in the first observation is 34.49 and the second observation is 31.92. Likewise, these all should be in the same unit. If the first is in seconds and the second and the remaining everything is in second. At the same time, in time on app, if the first is in hour, the remaining should be also in hour. So everything within the column, the unit should be same, but among the column you can have a different units. That is very important. So here we are going to find out yearly amount spent by the customer, for which we are using the linear regression, because the yearly amount spent is a continuous variable. We are using the linear regression to predict the value. And when we are giving the data set, we are giving yearly amount spent also in our training set, so that the linear regression model can learn properly within this data set, that can be used for new data set to predict the value. This is called the supervised learning. We have already learned. The next step is, what we should do is, we can have some more details for which we can do a chart. So the path chart, when we are executing the chart, it will show the relationship among the numerical variables, and whether it is a linear relationship or some other relationship, or the linear relationship is not that much good. All those things we can determine from this graph. These histograms are the relationship with the same variable, that is average session length and average session length. Then the same variable we can have a histogram chart. For if the relationship with is between two variables, then that will be shown in the in scatter plot. So we are interested only in yearly amount spent, that is the output variable for our linear regression. So how it is related with other variables, that is what we are interested. So when we see this one, the length of membership with the yearly amount spent is somewhat linear regression, that is it is around 45 degree. Then linear regression, this and so we can assume that it can have a high influence in the yearly members, has high influence on the yearly amount spent. So this variable can be used for our linear regression. The remaining three variables, relationship with our yearly spent is not that much linearly related, but the time on app seems to be somewhat linear. So we will check this up with some coefficient of correlation. Remember whether it is also linearly related to our yearly amount spent, for which we can use another one code. It will show the correlation coefficient with the heat map. So when we are entering this code, it shows the correlation. I mean how the yearly amount spent is correlated with the other remaining numerical variables. As we assumed, this yearly the length of membership has a high relationship, that is 0.81. In correlation relationship, 1 is the highest value and minus 0 is no relationship, and minus 1 is the negatively related. Here 0.81 is a good value, so the length of membership has a high relationship with the yearly amount spent. After this, the time on app, it is 0.5. It is also having a somewhat good relationship with the yearly amount spent. That is shown here also. It has a somewhat good linear relationship with the yearly spent. So these two columns, these two features we have identified, those are somewhat one is high linearly related with the yearly amount spent, and another one is somewhat linearly related with the other. But first we consider only the length of membership, because it has a correlation coefficient as 0.81, so it is highly related. So in our first iteration, first linear regression, we are going to consider only the length of membership and time on app. Both are having a relatively good relationship, so we are considering these two for our first iteration of the linear regression. Here the label is yearly amount spent, that is, the y value is the yearly amount spent. So we use these columns for our linear regression. So the input variables are time on app and length of membership, because time on app has the length of membership has a good linear relationship, and the time on app has a somewhat better linear relationship with the yearly amount spent. So we are considering this time on app and the length of membership for our input features, and we know that the yearly amount spent is the label for which we are going to predict the values. Okay, now we have a data set of x and y. X contains only two variables, time on app and length of membership, and y contains only one variable, that is yearly amount spent. The next thing is we needed to split the data as training data set and the testing data set. The training data set is used to train the model, and the testing data set is used to verify the model, because in the tested data set we have got actual values. When we predict the trained model, when we predict using trained model the values, predicted values, then we can compare this actual value and the predicted values to find out how the linear regression is performing. So now we are splitting the data, that is test and x and y. X and y, we are going to split the data into x train, x test, y train, y test. That means the x train contains these two variables of 70%, because the test size we say 0.3 means the training set is 0.7, that means 70%. The x test contains 30% of these two variables, and the y train contains 70% of yearly amount spent, and the y test contains 30%. That is the split we are making. For this code is used. So we are splitting the data into x train, x test, y train, y test. Now we are going to implement the linear regression, for which it is, because we have already loaded this package, so we can use this code for this linear regression. A linear regression model is created, and that is assigned with the name LM. Now we are going to give the x train and y train to find out the linear regression model. Okay, so we are giving the linear regression has been created with a data of S train, where S train is the input features and Y train is the output features of the linear regression. So the linear regression has been created. Now we are going to identify what is the coefficient of regressions. The coefficient we have already discussed in the theory part. Here we are saying that time on app coefficient is 37.25 approximately, and the length of membership is 62.8. The coefficient of length of membership is 62.78. That means if any change in time on app, for example, we keep length of membership is common, same, and if we increase 1 unit of time on app, then the yearly spent will be increased by $37.24. The same way, if we are keeping time on app is same, however the length of membership has been increased by 1, then the amount spent, the dollar spent will be increased by $62.76. This is the way we interpret the result. And the intercept is minus 172. That we know that when the values of time on app and the length of membership both are 0, then the Y value would be minus 172.296. Now we have come out with the linear regression model. The next thing is we need to verify the model, for which we are going to use the test data. So now we are using predict with the test data. Here we are only giving the S test, that is input features. We are not giving any output features, that is Y test. The reason is this linear model predict the values only with the input features. That predicted values can be compared with our actual values that are available in the Y test data frame. Okay, so the next thing is we know this result contains the predicted values. This result contains predicted values, and we know Y test contains the actual values. So these two are plotted in a scatter plot to find out how these two are related. So once we insert, this is a relationship with the actual values and the predicted values, and it is nearly 45%. The degree of our line would be nearly 45%. So we can be sure that we can be so much sure that and the relationships between these two are somewhat better. So to find out the actual values, then we can use the R squared, variance, MSE, everything using this formula. So when we get R squared, it is 0.888. We know very well that if the R square is very closer to 1, then the model is really good. So 0.89 is really a good relationship. So we can say that our performance of the model is good. And the variance is the variance of between the actual values and the predicted values. And this is the MSE, I mean the squared error, that is 711. It should be as minimum as possible. So our linear regression shows a value of 0.89 as a R square. It is somewhat closer to 1. So we can be sure that this relationship, this linear regression is working fine. At the same time, we have to find out whether it is possible to improve this model. So for which we can again go back here. We utilized length of membership and time on app as input features in the linear regression. After which this 0.36 average session length, it has also got a somewhat linear relationship with the yearly amount spent. Why can't we add this also to find out whether it is giving more performance to our linear regression? So the next time what we can do is length of along with the length of membership and the time on app, we can also add average sensor length as input variables to find out whether the newly created linear regression will work fine or the performance is improved from old linear regression to new linear regression. That is what we are going to find out in our next step. So what we will do is, now the X, that is the input pictures data frame, that contains average sessions also. That is, along with the time on app, length of membership, we are adding average session length as input in our input variable set. So because it has also got some relationship, so we are creating X as time on app, length of membership, and average session length. Now our X data set contains these three input variables. Y is the same. So now again we are going to split test data and training data for this new. Okay, splitter. Now we are creating the new linear regression model. The difference is we have added this average session length additionally to our input feature set. So the linear regression has been created. Now we are going to find out the coefficient. Now the coefficients can be changed from 37.24 to 38.74 by adding this average session length, and for length of membership, instead of 62 point something, now it has been 62.76. instead of 62.76, it has been changed to 61.77. Now we are using the test data to predict the value, and we will plot the both. So when compared, it is a finely tuned linear regression between the actual values and predicted values. So we can be sure that there would be some improvement in our linear regression. When we compare this to this, it shows a highly linear. So we can be sure that there would be some improvement in our linear regression model. That we will see it by getting the actual values of this R squared and MSE variance, everything. So what is our R squared now? Now our R squared is 0.98. It has been very close to 1. It is now very close to 1. So our performance of the model is very good. When compared to the previous model, it is 0.889, let us say. Now it has become 0.98. So a highly improvement in our model. And when we see the MSE, that is error, it is 700, squared error is 711.93. Now it is reduced to 118.688. So we have improved this model very well with the addition of the average session length. So the average session length also an important factor to predict the yearly spent amount. That is what we have come to, as a conclusion. So this is the way we can improve our linear regression model or any model step by step with the different kind of input sets or different processing of data, and that can be included into our input set. Likewise, we have to improve our performance. In our coding example, we used e-commerce customer data for developing the linear regression. The e-commerce customer data contains 8 variables, Among them, the 3 variables are identifying the customers that we are not using in our development of linear regression. The remaining 5 numerical variables, the earliest point is the output variable, that is what we are going to predict using our linear regression model. And the remaining 4 numerical variables are the input variables. The first step what we did is we found out how these input variables are correlated with the output variable earliest point. When I saw the correlation among these variables, we found that the length of membership and the time in app, these both input variables are highly correlated with our output variable earliest point. So in our first attempt, we developed linear regression using these 2 variables as input, and we found that the measurement R square value as 0.89. This 0.89 is really a good performance measurement and as a R squared value. So we came to the conclusion that this regression model is really performing well with our data set. However, at the same time, we were looking for improving our model, and when we saw the correlation among the variables, we also noted that the average session length had somewhat reasonable correlation with the earliest point. So why can't we use this average session length also in our development of linear regression? So that is the reason in the second attempt we also included the average session length in our input set. So now our input set contains 3 variables. One is length of membership, second is time in app, and the third is average session length. So the 3 input sets are 3 input variables are used to develop the linear regression, and now we have got the R squared value as 0.98. It is very close to 1. So we have come to the conclusion that the newly developed linear regression model is a high fit for our data set because it gives a high performance R squared value of 0.9. It is very close to 1. So this is the way we have developed the linear regression model step by step, and we also consider how to improve this one. So with this simple data set, we have developed a linear regression, and our aim of this demo is to understand how we can execute the linear regression. But in the actual scenario, before come to this data set, we have to clean and we have to find out other values. A lot of work involved, but for simplicity to learn linear regression, we have used this data set. It has already been processed. Thank you very much. Let us meet in our next educational video.